A Nephilim spider joining the monsoon banquet. She's caught a tiger butterfly. And he is utterly toxic. Butterfly predators need to learn this.
System error. Shutting down.
Walk, don't run. Use the handrails. Walk, don't run. Use the handrails.
Neon Temple simulation reboot in progress. Live stream initiated. Stabilizing environment.
Okay, and we're live. So, we are in week 3 of 4 for Back to Basics month. This is, again, like we mentioned last time, how the temple and its members give back to you, noobs who don't know anything, and also allegedly have essentially talks that we can keep on YouTube and within the guild chat of somebody who, if you don't know how to use Linux, if you don't know how to network, if you don't know how to do a thing, you can watch the talk and kind of get some idea on how to do it, as well as know who to talk to. So we are on week 3 of 4 of that with Patsy. Next week we're streaming. So yeah, for next week we are going into March doing the beta testing for the CTF. So Tremere and all of the Dungeon Masters, which if you are interested in Dungeon Mastering for the B-Sides Tampa CTF, talk to me or talk to Tremere, preferably me. Actually, no, but both of us should work. But yeah, so the way next week is going to go is we're going to have a bunch of tables set up. And if you are slated to be a Dungeon Master for the B-Sides Tampa CTF, oh, there's Tremere. What's up, buddy? Tremere's son is walking across the stream. Hey, Shane, you want to go over there real quick? Here, 1 sec. That was Tremere's kid.
I saw the top of the head.
Yeah. Okay, yeah, actually, so since Tremere just walked in the door, yeah, next week we are doing, like I said, if you are going to be a Dungeon Master, you are going to join a game of Paranoia hosted by Tremere, and you are going to learn how to play the game. And he is going to walk you through the nuances, and you'll be taking notes, you'll have your player character, you're going to die a lot, and you should, in theory, leave that game knowing how to play Paranoia. The month after that, so April, we are going to host another kind of, beta test night for the CTF, where you beta test the dungeon that you're building, because that was some feedback we got last year, was that people who built dungeons didn't really get a chance to test them out. So you'll be able to beta test your dungeon with people in the guild, and get feedback on that, and me and Furio, who are the head devs on the framework side of the CTF, are going to kind of be going around and taking notes, so that way we can, make sure that the framework that we're building out for the CTF platform works well with what you guys are building. So that's next week. The week after that is going to be the wrap-up of Back to Basics, and it's kind of funny. All I'm saying is the cult of Cochise has, definitely put out for Back to Basics month. So 1, and then Furio is number 2. So thank me for my service. But yeah, so Furio is going to. That was like a Sasquatch sighting from Rab. So yeah, Furio is going to put the cap on Back to Basics with a really, really good Python talk, and we know Charles Wong last year gave a good Python talk. So Furio is doing something a little bit different. If you suck at coding, and that's every single person in this room except for 2 people. Yeah, I know. Yeah, 1, 2. Even I suck at coding. Rab's really the only person I know who sucks at coding. Say again?
I know you suck at coding.
Yeah. Okay, 3. Yeah.
No, I do too.
Yeah. I think the only person who says that they don't suck at coding is Rab, and he can back that up. I know I suck at coding. I just suck a lot less than the rest of you. But yeah, so if you suck at coding, and if you're complaining because you can't find a job in cybersecurity, show up next week, take good notes, learn how to code, and show everybody that you're worth the damn that you're trying to be worth. So yeah, last week, yeah, and then we'll be moving into the middle of March. We got some really, really cool content coming up. Please check the Neon Temple calendar. The first month in April, and this is me also kind of telling Chris because he goes off of our calendar and we try and plan things out as far out as we can. Dr. Sunny is swapping for somebody's spot. So heads up, that'll go in the calendar. But yeah, Dr. Sunny's actually doing a really, really cool members-only secret talk at the beginning of April. I'm really excited. It is a it is a preview. But yeah, so those are all the announcements that we have. I think we're good. So we are going to get into some Linux Satanism tonight with our beloved little Patsy Poo Poo. Really quick, Mr. Patsy, would you tell us the history of that hoodie that you're wearing? Because I bet Chris hasn't seen that in like a couple Yeah, a couple
Yeah.
years. And
Abs-
how did you become Patsy Poo Poo?
Absolutely, yeah. So
Yeah, I know right now. Well, we own the IP, so.
Oh yeah, we own it back. That's why I'm wearing it because we got it back. Yes. So 4 years ago, I joined a club called the Undercroft, which is the predecessor to the Neon Temple, and the testing grounds. There you go. Yeah, the beta version of what is now our glorious temple. And from there, I met all of the whack jobs that run it, including Mr. Cochise. The beta, yeah, exactly. Yeah, and of course, we always had Mr. Macho Christ making this awesome gear. This is one of the amazing sweaters that he's got. It's got the old Undercroft thing, which we now own again. So it's okay to wear it because we have that IP. And yeah, this was back when I gave my first talk on Nmap and how to be too smart for the front lines. My title came from a small talk where the Count was trying to recruit Pisha Deal for a Black Ops mission in Venezuela or something. I have no idea what was going on. But he's like, oh no, I got this young kid. He's pretty good at the cyber stuff. I was brand new and I worked for a company that didn't know what they were doing hiring me. But he's like, yeah, no, he'll do it. He'll go to Venezuela and do whatever you want. And that's how I got to become the Patsy. Unfortunately, I never got to go. Yeah.
This is a true story.
This is a real thing. Hopefully that turns out again. He's got all kinds of
Okay.
weird Black Ops things
Yeah,
that he
so-
does.
No, that's actually a true story. So originally it was supposed to be me and Peesh, and then I may have said some things that made Paul a little unconfident in my ability to not cause an international incident. So the original plan was take some pictures and use those pictures to make money, and then Shane was going to go down there and take the fall for everything. Therefore, he was the Patsy.
Yeah. And that's still a goal. That's one of my career goals is to take the fall for one of Paul's exciting trips. But one day. So for now, you all have me. I'm still alive. I'm still not in a foreign prison. And I'm here to teach you about Satanism. As we've said, I'm your host, the token card-carrying Satanist of the Neon Temple, your heathen pal, the Patsy. And these are the valuable lessons of the occult of open source software. Before we begin, a quick little about me and why you should care about anything that I say. First and foremost, family man comes to the top of the list, husband and father. Very close second, because I've been doing it for a little bit longer, is the hacker man. I've had 8 years of the hackery this year. I currently work for a pretty cool job that allows me to do some pretty cool things. After that, I've got the FOSS Enjoyer. If you don't know what FOSS is, I'll get to that, but that's also a pretty big enjoyment of mine. And then finally, if you have the authority to demand I show up somewhere in a suit and tie, that's my government name. I'm Shane Cowper. Everybody else can continue to call me the Patsy. You're weird if you don't. Some things that I am not, and this is pretty important. I am not a lawyer. I'm not a financial advisor. I don't do either of those kinds of advice. If anything that you hear me say comes out like that and you interpret it as such, I'm not responsible for your idiocy. And finally, I'm not my employer. My opinions are my own. If you know who I work for, they didn't sponsor this. They don't even know I'm here tonight. So don't tie those things together. Standard stuff. And then lastly, yes, I am in fact a Satanist. That's a real thing. That's not just a meme. If you want to talk about that, for reals, you can hit me up in the dome or hand me whiskey and cigars after the chat. Also, I'm just some guy. I don't know everything. In fact, I don't even know the most about Linux out of everybody in this room. I'm just the guy that volunteered to teach the new people what I've learned over 8 years of using Linux pretty much every workday. So there's a good chance I'm going to get something wrong. I'm going to misspeak. I'm going to forget to say something. I guarantee you someone here is going to speak up and correct me. Please do. I encourage that because that's just better information for all of you. But also, if you have a question at any point, raise your hand. I'll be glad to take it. If you're remote, drop it into event discussion. Someone will ask it for you. Yeah. Pretty easy boilerplate stuff coming forward. And then, of course, here's the seventh tenet, basically saying dogma bad and don't worry about the written word and the spoken word. I can be wrong, and I probably will be wrong at some point, if not this talk, then a very close future talk. All right. Scroll down. All right, so let's jump into it. Pray tell, what is a Linux? This is geared towards people who are new, who don't know what Linux is, to some vague knowledge. So saith the Patsy, it's a kernel, and what that is basically a bunch of computer programs that let you run a whole bunch of other computer programs. And we'll get more into this. We're going to start at this very high-level definition and dive down, but we have to start with even more definitions. So what is a computer? If I asked you 2 weeks ago, you'd probably tell me, oh, it's that thing with the motherboard, and it's got the hard drive, and that's like the brain because it holds all the storage, and it's got the memory from the RAM, and that's all the short-term storage that dies when the computer shuts off. It's like the brain. And then you got the CPU that does all the instructions and like the thinking, and that's like the brain of the, there's a lot of brains in the computer. If I ask half this room what a computer is, they're like, it's that thing I use to embarrass C-suite and sysadmins. Both of these are correct answers, not really the one we're looking for. If we want to start off with the level that we're starting at, it's simply a magic box that runs computer programs. And then there's that word again, we got to define that. What's a computer program? Well, if you don't know what a computer program is, tune in next week. You nerds are going to learn from Furio. That's not my responsibility to teach you guys. Thankfully, that's a whole nother talk, and it's a whole long thing. However, the short answer is it's a set of instructions for your computer to do something, that hardware to do something. So if I want to run Minecraft, that's just me telling the computer, hey, here's a set of instructions. Take it and then display a pretty picture on the screen, right? Video games are just a slideshow, and it's just telling, hey, hardware, do some stuff, and then present a picture on the screen. Another program might say, hey, send this network command and then respond to me with the Windows domain hash, or send this command to this device and have it run a little roller over a piece of paper, and then it comes out with a printed document, right? All of these things are computer programs. They're just instructions telling hardware what to do. Unfortunately, or fortunately, because it would be very difficult otherwise, these programs aren't very readable to humans if you want to talk directly to the hardware. Back in the day, before we had operating systems, there were these really old computers that were the size of rooms. They had vacuum tubes. You'd screw them in manually or plug them in manually. I don't particularly know how it works. I've never seen one in real life. But they would, I don't even know. But they were very mechanical, and they would print out their output in a most mechanical way. Slightly less old than that, but still really old. I've never seen one. They had punch card programs where you take a punch card. I guess it was like a Scantron kind of thing, and you'd feed it in one at a time in the correct order, and then if you did it right, it would come out. Some people might have used punch card programming before in this room. If you have, I'd like to ask how your back is, because but these are all older programs. Nowadays, we have very easy programs. You'll learn more about what that's like next week. But they're very much like almost English to this point, especially if you're looking at Python. It's literally typing an English document to a computer. And computers don't really speak in English. They speak in ones and zeros. We've all heard that. We might not know what it means, but we understand, like, OK, computer language, human language, not the same. So for the in-between, we have a kernel. The kernel is the layer between the user space, everything that you do, and the hardware. So whenever you make a computer program that does a whole bunch of instructions, it doesn't talk directly to the hardware. It talks to the kernel, and the kernel translates that into the hardware. And they go back and forth. You never touch the kernel itself. Your programs do. Your GUI does. Whatever you're trying to do. And the hardware never comes to you directly. It goes to the kernel back and forth. There may be some exceptions to that. This is a kind of generic thing. There's always exceptions to every description. But this is the basic idea of what a kernel does, is it takes what you want to do and it translates it to the hardware itself, that bare metal. So a lot of you are like, I thought Linux was an operating system. You're saying it's this thing like a popcorn kernel? No, kind of, right? The idea here is that there are three major operating systems, right? You got Windows, Mac OS, and Linux. Yes, there are more operating systems that aren't those three. But the main idea is, or the main knowledge that most people have is these three exist. Some of you only know of two of them. That's fine. We know about the gaming and corporate one. Thou shalt put your faith and data in me, unquestionably. This is Windows. It's very good in the corporate environment. Very good for gaming. Why? Because it's closed source, proprietary. You can't edit things the way you want to. And companies like that. You make a lot of corporate deals. If you want to make games, you can make anti-cheats that read at the kernel level, and they're very invasive. Thankfully, Linux is getting better with that, with Steam OS, and being more compatible for gaming. But for the most part, if you work in corporate or if you want to do gaming, you're kind of stuck using Windows until, again, recently. We also have the clicky one, thou shalt not associate with the infidels. Even more private, even more closed source, even more proprietary. You have Mac OS, which is really good at, you have a MacBook, you want it to talk to your Mac earpods, and you want those to talk to your watch, and you want that to talk to your phone and tablet and all these other things. If you control the source code really, really tightly, you can make it so that it talks to the things that you want it to talk to. Problem there is it doesn't talk to other things very well. If you want to be a programmer for Apple or, God forbid, make games for Apple, it's going to be expensive for you as a developer because you want licenses, you're going to want accessibility to the software, a lot of things. It's no good. You're really restricted in what you can do. And that brings us onto the chosen one. Do as thy will. Ave Linux. Linux is a free open source software, FOSS operating system. It means that the kernel is available for you, or is open source and available for you to read. So if you want to look at a Linux system and you say, I don't like this, I wish that it had more, less, or did something better, you can look at the source code. Whereas Microsoft keeps it secret, Apple keeps it secret, and even if you got access to it, it would be illegal to modify. Linux says do it. We encourage it. We want you to do that. And then we want you to redistribute, which would be even more illegal if you modified Apple's code and then released it into the world. Linux is primarily focused on making that available to you. So if there's something that you don't like about Linux, you can be the change in that. Linux is all about freedom, doing things your own way, inventing your own rules. It's the best for you because you can make it that way without impedance. It's literally as good as you make it. Now, before we move on, there are a couple of honorable mentions because some nerds might get upset if I don't mention them. You have the flavors of BSD, which is a Unix operating system. Real quick, Linux is not Unix. You might hear that sometimes, like, oh, wow, that sounds similar. They must be the same thing. They're not. But Berkeley's software distribution has an operating system that is Unix-based. It's probably the most popular one that you haven't heard of. It's really big with things like networking or the network devices for the most part. Feel free to try that out on your own time. We're not going over how to do that. The other one you've probably heard of, if not recently in the chat, is Solaris. You can check X or Twitter for the latest CVE on that one. That's Oracle's punching bag. It's really popular with cloud networking or enterprise. These two, unless you work in that sector, you're probably not going to see them. And if you work in that sector, you know way more than I can tell you. Finally, my favorite that is not Linux is Temple OS. And Temple OS is a really, really weird story. I encourage you to look at one of the many YouTube documentaries. It was made by a guy named Terry A. Davis. A guy, yes. He had some mental issues. He was schizophrenic. And he designed this as the third temple prophesied in the Bible, this operating system. And he made it himself from scratch. It's not Linux-based. It's not based on anything. He made it himself. And not only did he make this operating system, he made the coding language for it. C wasn't doing it. C++ isn't doing it. He started with something called C++, but that name didn't stick. The name that stuck, the programming language that he made to make his own operating system, Holy C, which I think is a fantastic name for Temple OS.
So you're telling me that there is Protestant-based Linux?
Yes.
Okay.
Which, of course, there is. There's Linux based on everything.
Yes.
When he released it, he put on the website a quote, "God's temple is finished. Now God kills CIA until it spreads."
Go on.
Yes. He was schizophrenic. He thought that the CIA was after him. He unfortunately is no longer with us.
I mean, like, you don't need to be schizophrenic to think that the government's after you.
Fair, but to...
Wait, you're saying that, hold on, the CIA was after him?
So Rabbit's going to do another talk on Terry Davis. Whoops. Yeah, so that's, again, Terry Davis, Temple OS. Look up a YouTube documentary. It's cool stuff. I just don't have the time to go into it. All right, so speak plainly. Is it an OS or a kernel? What is Linux? And this is where nerds get really pedantic. It's not a simple answer. What's a kernel? It's that part that interacts as an interface between the hardware and user space. We went over that. I'm not going to dive too much more into that. So it's not an OS. It depends who you ask. Richard Stallman says no. He likes to go by his initials, RMS. He says the OS is GNU and Linux is just the kernel part of the operating system.
He's also wrong.
This is where nerds get into the fight.
Nerd fight!
So what is GNU? It's a collection of software, including the bootloader, init, GCC, glibc. It's a whole bunch of software programs. It's a bunch of packages that RMS wrote. And now at this point, it's like 394 or something from the GNU project. So there's a lot now. It's not just him anymore. But he wrote these. And they are necessary for the operating system to run. You can't run an operating system without these kinds of programs. You can't run an operating system without a kernel, right? As I said, the Linux kernel it's the middleman that lets these instructions run. And it was actually built using GCC to compile the C code that was later into the Linux kernel. Also, Linux is an OS. Even if you want to get into the pedantics, there are Linux operating systems, Android, Alpine, DDWRT. These are just the ones that I found with a quick Google search. They do not fall under the GNU/Linux debate. They are their own things. You can probably find more if you Google it, but yes, Linux can absolutely be an operating system. And then here's a quick view of what that means. We got the kernel sitting in the middle of the user mode and the system library. System library is things that are often found in GNU. There's other stuff in there. Essentially, this is just the separation between the hardware, It's a nice little graphic because some people like pictures. So the actually, here's the famous quote. You're all going to see it a million times as you get into Linux. It starts off, what you're referring to as Linux is in fact GNU/Linux, or as I've recently taken to calling it, GNU plus Linux.
I can smell that picture, by the way.
Richard Stallman's a smart guy, all right? I'm not going to say...
Does he know how a fucking shower works?
He knows how GNU works, right? He says we should call it GNU plus Linux, GNU/Linux, because Linux is just the kernel part. I kind of went over this. But this is the famous copy pasta that you'll see a million times if you ever look into anything in Linux and you get into it. So let's look at a quick history. That's just the kernel. I did all of the hard work. Yeah.
It's really LS that's the big deal.
And GCC, don't forget GCC. So let's look at the history of this and why he's saying all that. Way back in 1983 is when we start to see this come out. At this time, AT&T owns Unix. And that OS is going to make them rich. They're already rich, but they're like, yeah, this is our proprietary operating system. You can't edit this. This is our Unix operating system. It's closed source. It's our proprietary software. And Richard Stallman's like, that kind of sucks. So I'm going to go ahead and make this library called GNU. What does GNU stand for? It stands for GNU's not Unix. It's a recursive, they call them recursive acronyms. The G stands for GNU. It's annoying. You see this a lot in tech culture for some reason. But everything, when he releases it with this quote, everything useful that normally comes with a Unix system so that one could get along without any software that is not free. That's what the GNU library is for.
I have a question.
Yes.
Give him the mic.
Give him the mic.
Have the wise folks of GNU ever attempted to produce a kernel, which they think is just a side effect of an operating system?
Yes, they did, actually. They have tried. We'll get into that. Yes, they have tried. Well, they've tried to make a microkernel, if you want to make that distinction. Spoiler alert.
I'd say it's just average, but...
I know you would, John. But yeah, so he releases this thing, which is great, because Unix at the time, kind of like the standard, and now we have a free version that's open source, right? And GNU is born, and then we have this logo for it. We got everything ready to have a fully functioning operating system, except the kernel. That's kind of an oversight. Meanwhile, in Finland, we have this guy named Linus Torvalds, a university student that just so happened to be developing a kernel for funsies. He has a book literally called Just for Fun. I haven't read it, but I discovered it today, or during the creation of this slide. Definitely adding to my read list, but I think Just for Fun is a pretty good idea of why. Eventually, we bring Linux into the public domain, and he releases it with the GPL license in 1991. So now it's free for everybody, free open source software for everybody to use with the GNU library. And hooray, now we have the, what is this, Club Penguin Tux mascot, and then this cow thing. Obviously, we use the penguin for Linux as a mascot. Not really sure why we have a cow for GNU, but the sad part is this is never officially adopted by GNU. This is not a official kernel of GNU. So why aren't they the same thing? Why do we have all these libraries that Linux needs to run, and Linux needs all these things to run? They're kind of inseparable. So the passion behind this is so I created them free, and free they must remain. This is one of the things that I really like about RMS, and there's a lot of kind of negativity that we've heard in the room towards him. But he has done a lot of great things for the free open source software community, and I got to give him credit for it. And we're going to go ahead and do that right now. What did he do? He's got 3 really big contributions. He made the GNU personal license, another recursive algorithm or acronym, and this keeps the open source open source. Basically, what that means is it's a license agreement, one of those legal things that you hit accept without running or reading. You attach it to your software, and it says anybody who receives this free open source software is allowed to modify it and redistribute it, maybe redistribute it. And if you redistribute this software, if you send it to anybody, you must include the source code. Free does not mean monetarily free. You can still charge for free open source software. Free means free as in the modification of it. So if you release the software and someone modifies it and then they wish to redistribute it if they're allowed, they also must use it under the GNU GPL license. So this keeps every iteration going free and open source software so that everybody who receives it is allowed to modify it the way that they wish. And this is a really, really cool thing. This is absolutely great. It's on version 3 now if you want to read it. It's not that hard, and the first paragraph kind of sums it up. But this is a really great thing that he's done. And under this ideology, he's also founded the Free Software Foundation. It's just a foundation dedicated to influencing the world as he can under this kind of idea. And then finally, of course, he wrote GNU, at least the early version of it. The modern version of 394 is maintained, I think, by FSF or the GNU Foundation. One of the two. It's up to 394 libraries, I believe, as I mentioned. And it's a pretty great thing. A free version of the Unix without the kernel, built from the ground up with original code that he could release so that you could get around the Unix paywall. This is really important. He made it all from scratch, so you can't sue him as Unix or AT&T for the things that he made. He made it all himself from scratch, just copying what the functionality was. He didn't use a line of your Unix code. What he didn't do is he did not develop a kernel for GNU. There is HERD, which is the GNU microkernel. It has not been touched since. Oh, question.
Yeah, this probably comes from a blatant misunderstanding of how everything works, but we're working on clearing that up. How did he go about creating something that is similar in function, but is patently different enough to not get sued?
All right, so the question was, how did he make a library of things that Unix had that is different enough to not get sued while still doing the same thing? And the answer to that question is more or less, it's really easy to make 1,000 ways to skin the same cat. And laws, especially back then,
So when there's only one of something?
Thank you.
When there's only one of something and you're a computer engineer and a hardware engineer and the only thing is how to make spaghetti, if you go home and say you're going to make a different meal, it's going to come out looking a lot like spaghetti. So he knew Unix. He knew how Unix worked. He knew how the computers ran at the time. He knew the instruction sets that were used in Unix. And so he went and said, I don't like Unix, so I'm going to build a new one that just happened to look really damn close to Unix.
Okay, so you just like skirted patent laws quite closely, added to the functionality.
So it's copyright code.
Hang on. You got it?
Oh.
Not Mr. Jeremy's head.
Smoked fake Jeremy.
We can see why John plays with computers and not sports.
You know, you guys really don't take Mike Fragility very seriously, but that's kind of
White
a,
fragility?
Is the sound still?
Sidebar real quick. So, Macho, Elvira was telling me about, like, it's like a mic in a ball that you can throw around and yeet at people. I want to pick one of those up for the temple. Okay, go ahead, Reb.
So code is generally falls under copyright, and copyright is like, if you imagine you write a short story. Well, if someone else writes a short story, that's not the same short story. Just like if I write a program, it's not the same program that you wrote. Even if it, at the end of the day, does the same thing or a similar thing, it's still not the same program. I didn't copy the 600 lines of code or whatever it was to make that, or 10,000 lines of code to make that program work.
Okay.
So that was the issue with like BSD was apparently there was actual like copy and pasted code from the original BSD kernel that went into, or from the original Unix kernel, sorry, that went into an early version of BSD and caused a big legal finagle.
Kerfuffle.
When was code like actually protected under copyright? Like I'm sure there had to be.
I think it was automatic
When you're
because it
willing to
was,
kill John
if you write something, it's copyright.
And is it
Yeah.
Falls under.
Oh,
like
you don't know
book
that. You know that.
copyright where it's like the lifespan of the creator plus 70 years or however long Mickey Mouse wants to continue to be copyrighted?
Yeah, I was about, because that was like 150 years or something.
Yeah.
When the creator is a corporation, it gets complicated because they live forever.
Oh, okay. Okay.
And they have lobbyists to make sure that they live forever and
Yeah.
that their rights are protected above and beyond yours.
And that they freeze their heads.
Yeah.
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 Walt is still waiting on the quantum.
So there was actually an episode of Robot Chicken about that where they froze Walt Disney's head and put it on a giant crab bot and it went to Cuba and tried to eat Elian Gonzalez. That was pretty funny.
And the crab bot ran Linux.
There you go.
You mean GNU Linux?
All GNU
Bigot.
Linux there. All these squares make a circle. Yeah, so copyright lasts as long as you have money. But yeah, so we got the herd kernel in development, microkernel. It hasn't been touched since before I started working. My first ever job was 2017. Their last update was 2016. So we're not really hopeful for the microkernel of GNU to come out. You know, it's kind of like the owl thing, right? How do you make an operating system? You draw the sim circles, you draw the rest of the fucking owl. He forgot the rest of the owl. The kernel is a little important to an operating system. We're missing the owl.
Step 1, draw circles. Step 2, draw rest of fucking owl. Can we put that on a shirt?
Yes, you can. So what did Linus do? Linus Torvalds. He wrote some little home project where he got this computer for Christmas. And he was like, man, I really like this, but it's got Minix on it. Minix was the educational free version of Unix. It didn't do a lot of the things that he wanted it to do, and especially in the way that it talked to other computers back in the ancient days of networking. So he was like, man, I really wish that I could use my personal home computer that I got for Christmas in the way I want to. This GNU thing is out, all right? RMS has already released it to the world. I'm just going to write my own kernel for it. As one is wanted, and that's it. He was just like, this is my home project. I want it to come out, and he did it. Like, he did have some experience. He was a student working on his thesis at a Finnish university that I can't pronounce, but he was a student and was just like, I'm bored. I'm like 21 years old. I got some free time. I'm going to write a kernel. Some other things he did. Finland has a compulsory military service. I thought that was cool. I didn't know about that till I started making this. He served as in the Finnish Navy and retired as a second lieutenant artillery observer. I don't know what an artillery observer does. I just thought that was a cool thing that I've never heard about Linus, and now I'm more unique than everybody else who talks about him. He also created Git. So back in the day, if you know what Git is, it's just like a way to track changes in your code repositories. It's like a version tracker. Back in the day, there was this program called BitKeeper, and it was closed source, it was proprietary, and Linus was on record for saying, oh, all code should be free open source software. This is the best way to do things. And some nerds were like, Linus, you use BitKeeper for your repository. So he's like, all right, I'm going to write Git, and that's how we have Git, and that's why it's free open source software. Praise Linus, right? Like he was just like, all right, fine, I'll walk the walk, and I'll make a thing that does the thing that I
What if
stand
we
for.
work at a poverty company that uses Subversion?
Then work for a better company. Sorry.
Quit.
Why would you work for someone that doesn't use Git? I don't. If you're a software engineer and you don't use Git, I don't know why. Question. What is Git? Git is a software, it's grown now, but it's a software versioning tool. Essentially, if you write a program, and especially if you want other people to be able to view it, track it, edit it, view the open source software, you upload it to this website called Git, and they can download it, and they can see the source software or the binaries if you don't want to share your software source. You can attach a license to it automatically as soon as you create it or release it to the public. And then those people can do some edits to your code and push a code request saying, hey, I made this edit, whether they work for you or whether you just posted it to the public internet and someone was like, this is really cool, I want it to be better, right? So it's just a really cool versioning tool. It tracks all the changes. It's like Word for software, but good. Go ahead. Oh, okay. Next question.
Very dumb question, I feel.
That's
wait.
Oh, no, I don't know.
You got to get the mic. You're good. No, come on.
He's a member now. He's got to be documented for all his dumb questions.
One of us. No dumb questions for this talk. This talk is all about dumbness.
Just because I'm curious, is that where GitHub kind of got its name? Is just from the creation of Git being an open source?
Same thing.
Oh, are they the same
Git,
thing
GitHub.
exactly, or like
I mean, it's
separate things?
Basically, Microsoft acquired and what some might even say stole Git, but
yeah. So Microsoft still get
So Git is a change management.
There we go.
Git is a change management tool. GitHub is the repository that Microsoft tried to pull all things together for Git to make a central source. Because everybody used to host their own little Gits all around the internet.
So originally, Microsoft didn't own GitHub, and because Microsoft hasn't come up with a unique idea since the 1980s, they kind of did what Disney World did, or what Walt Disney did, and they bought Git, and then said, oh, look at all of our revenue increasing, and they only, they spent $10 million in order to make $30 million. But regardless, Git is essentially the version control software, and it's a common language, almost like SQL or MariaDB. It's a common language shared across platforms. Just because you have Git doesn't mean you have to use GitHub. You can have GitLab, you can have Git Mesh. GitLab's pretty cool. It's an alternative to GitHub where Microsoft isn't scraping your code and then copywriting it if it's good. And you can also self-host your own GitLab instance, which if you want to not suck, then yeah, try that. Try self-hosting your own GitLab image.
Is that true? Do they still code?
Oh fuck yeah, they still code.
I mean, what does Microsoft not steal?
Waffles.
But do they copy?
Are you sure? I'm
Oh.
pretty sure they do.
Like copywriting it for yourself.
Well, okay, so whenever you put something on GitHub, aside from like the multi-page legalese terms and conditions, which pretty much means that, if a Microsoft lawyer pounds on your door and says, we want to do things to you, they can. Just because did you hear about, sorry, I'm stealing Shane's thunder.
No worries. The Disney thing?
The Disney thing, yeah. Okay, no, so some guy, or maybe it was his wife, somebody dies at Disney World, right? Yeah, somebody dies at Disney World, and so the surviving spouse goes to sue Disney because it was gross negligence on Disney's part. And so he goes to sue Disney, and then Disney comes back and says, nope, because you're a Disney Plus member, and we found your membership from like 10 years ago or something, and you were a Disney Plus member, and you signed as a part of the terms and conditions of Disney Plus that you won't sue us. You have to enter into arbitration with us. So fuck you. Pardon my language. Yeah, and say again? Yeah, it was upheld in court.
Did they get arbitration?
Yeah, and they got washed. They got hosed. Yeah, and so.
Because they subscribe to a streaming service that
Yeah.
Yes.
Moral of the story, kids: binding arbitration clauses are cancer.
Yes.
Yeah.
And so the point where I'm going with this. Okay, Rab has something to say. Hang on.
To add a comment about.
You gotta get the mic.
Okay, yeah, we'll bring the talking stick over to Rab in a second, but the point of that is whenever you put your code up on GitHub, because Microsoft is hosting GitHub, and they don't say they do this, but everybody knows they do this, they'll scrape repositories and be, oh, this is interesting code, yoink, and then this ends up in a Microsoft product, and just like you had to, like what happened if you drew Mickey Mouse 3 years ago, if you try and rip off of Microsoft, then they'll just come to your house and...
I mean, that's Adobe's
Yeah.
entire.
We know where our bread is buttered with Adobe. Okay, Mr. Rab. Yeah.
You stood Rab.
Git is not GitHub. So just to clarify this, like Git is not even a GUI. It's just the software that keeps track of text files, basically, and it's versioning those text files. So like if you needed to roll back 5 versions because you found out you introduced a bug, you can do that and be like, oh, I made this bug. So you don't, if to use Git, you don't need GitHub, you don't need GitLab, you don't need anything but Git, and you can put a Git server in your house. You can find hosted Git servers. You can do it on Amazon or whatever you want to do, or you can do something like GitLab where you have a GUI in front of it that has a nice little web interface that's like, oh, look at my highlighted code on the web browser, great. So just lest anyone think that GitHub and Git are like the same thing. They're not.
And
A
they're,
lot of Linux talk would get a bunch of nerds worked up over this.
See, that's
every year since I came into IT, I heard that this is the year of Linux. And Tremere was kind of the one who shot that argument down of like, it's never going to be the year of Linux. Drop down and do 30 push-ups, nerd.
yeah.
Yeah.
So
Oh, no, I think it'll be the year of Linux before it's the year of IPv6. But yeah, to Rab's point, Git and GitHub are two very separate things. Kind of like there's pizza and there's Little Caesars. I mean,
One's good, one's bad.
I love Little Caesars. You can fuck right off. Yeah, I mean, I use GitHub. We use GitHub at work. I also have my own GitLab at home, which if it's personal projects that I'm running, I want it on my servers where I can touch the thing. Because you can self-host GitLab, and especially if it's self-hosted on something that you own at your house as opposed to a VPS in DigitalOcean or something, you can put your hand on that server and touch it. And I think that's valuable. And that means if somebody wants to try and steal my code or do something malicious to me, either I didn't configure GitLab good enough, which is my fault, or you've broken into my house, and then I'm going to, pull a shotgun on you and reenact Deliverance.
all right.
Allegedly.
Yeah. So that's actually, and the comment was made, how are you going to get a whole bunch of, or how to get a whole bunch of nerds arguing? That's part of what I love about the guild, is that I can come in here and not be the smartest person in the room, and I really hate being the smartest person in the room. That means that I'm in the wrong room. So I started to answer that question very poorly. I said same thing, kind of. They're not. Everybody got very upset about that, rightfully so. But yes, that's a pretty detailed answer, and I'm going to move on before I run over my time. All right, he also stayed incredibly based. If you ever read any correspondence that he has, it's so good because he's a very intelligent person, obviously. And he loves destroying people with it is a good thing. The Linux Foundation, up until a few years ago, didn't have a code of conduct. They had a code of conduct. They had a code of conflict. This is a real thing. Everything that he says, except for the one that I'm going to show you, is just like, this is why you're wrong. I don't know why you're trying to push so hard for this. Stop. Like, this is the detailed reasons. Move on, find something better. You're a smart guy, but like, this is not the hill. So read anything you can find from Linus. It's so good. And you learn a lot. But he had humble beginnings. This is the release of Linux in a system that most of you probably have never heard of. He says, hello everybody out there using Linux. I'm doing a free operating system, just a hobby. Won't be a big deal or professional like GNU. It's only made for this specific super old computer none of you have heard of. And I'm just asking, polling the internet. What do you like? What do you don't like about Linux? Any feature suggestions? It's just a hobby thing. Don't expect much, and don't expect it to ever run on anything more than what I have at my home, because that's just what I got for Christmas. And I'm a poor student. And then that's the name of his university, Helsinki. We'll go with that. That's his old university email. And then this is pretty much what all of his communications look like if you ever find them. Yeah, so nice little thing. And then that leads us to the protest, which we've probably heard a little bit of. It's long. The Linux community has typed out this response to RMS, essentially saying, no, Richard, it's Linux, not GNU Linux. I'm not going to read the whole thing. It's long. It's kind of annoying. The TLDR is, how are you going to have an OS without a kernel, nerd? Which is a valid question, because some would argue that the kernel is the operating system, right? Now, here's the Patsy's hot take. Both these guys are smarter than me. Nothing but respect for RMS. Nothing but respect. Herd has not seen development since before I started working. As I mentioned, his microkernel. Linux remains the most popular for GNU. It's not for GNU. It's not close, and GNU needs Linux a lot more than Linux needs GNU at this point. As nice as GCC is, it's just not necessary. As the meme states, I don't name any of my code GNU/Patsy school script.out just because GCC compiled it. So if you want to have your operating system called GNU/Linux, release your kernel, call it GNU/herd, call it herds, call it GNU. I'm not going to add extra syllables to Linux just because you wrote a whole bunch of libraries for it. Sorry.
But then you get DEF CON talks.
I'm too lazy. Yeah, then you get DEF CON talks, but like I have a soul still, even though I'm a Satanist. So.
Why is it every guy who's associated Linux at a high level looks like Ted Kaczynski?
I thought it was the same picture. I'm gonna be honest.
I think you answered your own question.
Yeah, is it the same guy?
No, it's an old picture.
I'll leave it up to the crew to debate. But yeah, always yield to the hands-on imperative. You want people to call your operating system and kernel, make a kernel. So that's Patsy's hot take. Not everybody agrees. It sounds like a lot of people agree. But so that's nice, right? A nice long history lesson. Who cares? This is a lot of nerd drama, politics, and history. We have a whole bunch of hands. Linux nerds do. Thank you for raising your hands, calling yourselves out.
Who did you write this for? Well played, Patsy. Know your audience, Patsy.
I do.
Know your audience.
This is a big part of tech culture as well and should serve as inspiration to you, and I'll get into that in a second. You're initiated now. You're one of us. You're one of the nerds, and you'll hear this discussed sooner or later, so now you have a lot of context behind it. Why this should inspire you. And yes, I know, a Rick and Morty quote, roast me later. But he says this in response to therapy. I don't agree with his take on therapy. But he says, I'm a scientist because I invent, transform, create, and destroy for a living. And when I don't like something about the world, I change it. On therapy, he says, I think it's helped a lot of people get comfortable and stop panicking, which is a state of mind we value in the animals we eat, but not something I want for myself. Or to put it a little bit more succinctly by the guy who created the three-ring circus, comfort is the enemy of progress. If you don't like something about any of the software that you're using, especially if it's free open source software, you have the ability to create, destroy, change, add, subtract. There is a Linux for everything, all right? You have Hannah Montana Linux, which is themed for Hannah Montana's superfans. It's pink, it's beautiful. You have, if you're a dictator, Red Star Linux. Is it good if you're the dictator of North Korea? Yes, right? That's the one that gets released to the people of North Korea. He made it the best version for himself, and you can do that. He had his engineers under gunpoint make it for himself.
It literally looks like North Korean Mac OS. It's kind of cool. I've used it before. No, I have the ISO for Red Star if you want it.
Yes.
If you the North Korean TV?
Yeah, did you post
that was me.
Yeah, you posted
Yeah. Well,
Okay.
I'm not radicalized. I just like North Korean stuff.
All right.
You think they have that other OS, like, click here to watch our TV?
Maybe.
But Patsy, if I want to make my own Linux, don't I have to know how to code?
Kind of. Not necessarily, right? So you have, let's take Ubuntu, for example. What is Ubuntu? It's just one of the distributions of Linux, right? Then you have Lubuntu. What's Lubuntu? It's a lighter version of Ubuntu. That's not for Ubuntu, right? It's Ubuntu with things just taken out. It's less Ubuntu, and it's its own distribution. They removed things. They destroyed things. What's Xubuntu? And they're all based on Debian. But that requires code.
Who cares?
Oh my God, who cares? Xubuntu or Xubuntu, however you say it, I don't remember, is just Ubuntu with a different desktop environment. It's a prettier color. You don't need to know how to code to make your own version. If you want to like really improve it, you probably want to know how to code. And if you're in the guild and you don't know how to code, we're just going to bully you. So learn how to code. But no, you don't need to know how to code. You don't really need to know how to do anything. Or you can invent new ways to code, right? Again, Temple OS. It's not Linux-based, it's not Unix-based. It is its own from-scratch operating system based on a language that the guy wrote libraries for. He built on C, which is impressive. Like a lot of languages are built on C, so that's not a detraction from it. He wrote Holy C, right? So you don't need to learn how to code, but learn how to code. But yeah, if you don't like something, change it, make it for yourself, right? Lighter versions are just better for some people. It has less stuff and it's better, right? You can. Same thing applies to your job. Absolutely. Yes. If you don't like it, change it. Well, if you're able to change it, there are asterisks there. But yes, try to change it and do better for yourself if you don't like your job. All right, so that's enough of the nerd drama politics. Let's get into the technical stuff. Almost an hour in. That went a little longer than I had practiced, which I kind of expected anyway. Here's a quick rundown of what I'm going to try to get through. We're going to try and get Linux installed. I'm going to run through this very quickly, mostly with screenshots. If you didn't come with a Linux system running, you're not going to be able to do this with me. It's going to take too long. Once it's ready to go, we'll do basic commands. We'll reject the GUI and embrace CLI. We'll do some neat tricks, thinking with pipes, some automation. We'll do remote access, how to use other computers while you're on this computer or your computer. We'll start getting offensive, nothing personnel, kid. A little sneak peek into LFS, and then we'll look into ways to contribute to the free open source software community. All right, so installing Linux. All right, so the first thing that everybody's going to ask, including myself when I first started, is which distro do I use? And the answer is, what do you want to do? This is like asking, what tool am I going to get from Home Depot? We can't answer that question for you without a lot of context.
Hammer.
Well,
It's always a hammer.
it's always a hammer. Everything's a nail when you got a hammer. Well, it's always Ubuntu. How many choices do you have? A lot. Because everything that you change, like I said, you take something out, that's a brand new distribution of Ubuntu, just because you changed something small about it. And there's a lot more of distributions than just Ubuntu. Actually, and just for a quick sneak peek, here is the Wikipedia timeline of operating systems. You got Slackware Linux, I'm sorry, just Linux soft operating systems. And this branches off into all of these things that you've probably never heard of, especially if you're learning things from this. You got Slackware ARM, SlackOS. I haven't even heard of most of these, so don't feel bad. And then you get into the Debian branches. Oh, SUSE comes from Slackware. Debian comes out with all of these things. There's a lot, and we'll just zoom out. But Raspberry, Kali, Tails, all of these things are Ubuntu. This one, I can't see. Red Hat, thank you. That came out with Fedora. That came out with some other things. There's the Arch Linux one that has Black Arch, that has a whole bunch of other Arch distributions. There's a lot of Linuxes out there, and some of them are just kind of one-offs, right? So you have a lot of choices of Linux to try out. The short answer is I can't answer that for you. But for the purpose of this talk, we're going to start out with Ubuntu, because ain't nobody got time to go through all of them. Why do we do Ubuntu? It's the most popular, which means that when you inevitably have a question, you can Google it without bothering all of your friends. Because if you're new, there's a very good chance that you can Google what problem you're having. All right? Because most popular. It's the most popular for newbies. For not necessarily, you know, a billion devices run on Java, but Java's not the most popular programming language. So no, it's not the most popular in existence, but it's most popular for people who are trying it out as a desktop operating system. So we're going to do that for our talk. How do I convert to the Ubuntus? That's a great question. I already did that, broad stroke, the other distros. If you want to know more about things, you got Fedora, which is really big for the free open source software people. Ubuntu, like I mentioned, is the lighter version. You got Debian, which is like the source of a lot of things, including Ubuntu. And it's great. You got Pop! OS, that's Debian-based. Kali, Parrot, and Black Arch if you want to be a hacker. Don't do that if you're just trying to learn Linux. Arch and Gentoo, I really recommend Arch and Gentoo if you really want to learn what Linux is all about on the back end and getting deep into it. We're getting the symbol, but no. Download Arch. It's easier now. I'm hearing that Gentoo is the way to go if you want to learn. I haven't done it yet, but it's on the to-do list.
What about cold, elevated, climate-based Linuxes that I could put on my network equipment?
Cold, elevated, climate-based network devices. I don't know if the operating system.
Oh, you said it earlier. Come on.
Oh yeah. Okay. So if you want it to be themed in a cold tundra environment, you could just do it without a GUI or.
No. So Alpine Linux is.
Oh, Alpine Linux is what you're going for.
Alpine Linux runs on a lot of network equipment.
I did not know that.
It's very sparse.
Okay.
I guess that's why they called it Alpine.
That makes sense.
It's a lightweight.
I didn't know Alpine Linux was for that. I did know that it was made without GNU. It's its own operating system.
Only for that, but yes, it's for that among others.
It's that. Well, everything is for that among other things. Unfortunately, everybody likes to stretch everything. There are people who use Kali as their everyday while they bank.
Who? I need to find them and bully them.
Me, 2017.
You get a pass.
I get a pass. All right. Yeah. So, huh?
Oh, we'll be at Root. Yeah, in 2 weeks we'll be at Root, and I'm gonna do like you and me can tag team in and make the kids hopeless again.
Nice. So here's how to do it. If you can't get to this step, you need a more easier class on computers. Maybe your local library has a seniors class. Download VirtualBox. It's simple. It's easy. You click the double click the XE, and it installs. You follow the instructions. Download the ISO. You go to Ubuntu ISO in Google. I wouldn't do the LTS so that you do struggle. LTS just means long-term support. It gets less updates, and it's more stable for people who are trying to do businesses on it. This is the standard version. This is the one that I use, and this is the one we're going to go to. You download that file, and then you're going to verify this file. And we're going to go over this because nobody ever talks about this, and nobody ever does this that I see. When you download the file, it's going to say, hey, do the checksums and get this key. You can find these files in Google if you forget to download it. But these are for verification, right?
Just want to make sure before you.
Gosh damn it.
Realize the room you're talking to when you say no one validates checksums.
No one who teaches these classes online tells you to validate the checksums.
Okay, fair enough.
I will correct
I think
that.
the last time I validated a checksum was like before COVID. So
Hey, I got
Okay.
some distros I'll send you.
please do. To be fair.
Well, we're going to hash using Windows, which is surprisingly not too difficult. So, yeah, always choose the right tool for the job. That was part of Linus Torvalds' philosophy. That's why he's not admitted into GNU. A big part of it is he says, use the right tool for the job. Yes, free open source software is the very best thing, but the actual tool that you should use is the one that gets the job done the best way. So he'll use proprietary software, and I follow in line with Linus on that one. If I have to use Adobe to read my PDF file, which I don't anymore, thankfully, I'm going to download Adobe, and I'm going to get my job done and not struggle with Arch for 30 hours trying to figure out an open source PDF viewer and editor. You got to prioritize what you do. Don't use Arch. Well, or Fedora, all right. Sticking to the open source repositories. How do you get NVIDIA to work without proprietary drivers? Don't use NVIDIA. But anyways, so you download these two files. Right click and save them. You cannot open them and copy paste them into a new one, especially not this one, because it is a file that is called signed with that GPG key. If you don't have the GPG keys, well, let's go over quick what GPG key is. If you want to verify a file is the way that it is, there are two little pieces of information that you need to do that. You have your SHA-256 sums and your GPG keys. The sum is basically you take a file, you do math to it, and it comes out with this long string of random letters and numbers. If you do this math to a file, you'll always get the same answer unless you run into a collision, which with things like ISOs is really, really rare. So that way you know that, hey, this is the same file that made this math thing. Rare or deliberate. If you downloaded an ISO for Ubuntu and it's a hash collision, they deserve the win. I'm just going to give it to them. The other thing that you need is the GPG key. And the GPG key is very important because this has a little key in it that says, hey, I signed this file. The SHA-256 sums that I am sending you is the same one that I made when I made the website and I uploaded it. What that means is if someone hacks the website and they're like, here, these are my hacker files, you know that's not the case. There are ways to get around this. It just really, really complicates the whole ordeal. But this is just verifying. You're verifying the verification, and then you're verifying your file. If you don't have the Ubuntu keys, which you probably don't if you're running Windows, you can pause the video when you go do this. These are the commands. Don't blindly copy-paste commands ever. Read what they do. Figure it out. But this is just GPG, which is the software that does keys. We'll get into an encryption talk at some point, cryptography talk. Key ID format long. Just accept that that's a thing. Before we can get into that, we're verifying that this and this match. I can't do that because I don't have the keys, so I'll go ahead and download the keys from this key server. This is the key that I want, so I download it. I add this little 0x because that's what the website said to do. And then we'll go ahead and retry it, or we're going to verify that this downloaded correctly. And when we look, we see that the website here fingerprint matches, and that this is the Ubuntu automatic signing key from 2012. So a pretty good chance that this is the correct signing key, which means that this file for the checksums is probably correct if it matches the GPG file. So we'll run this command again. It'll work. It'll say, hey, good signature. It's signed correctly. We look good. Again, if this is all confusing to you, you don't really need to know the math behind it. As long as you understand the process is download GPG key, download checksums file, make sure that it's signed correctly, and then make sure that your hashes match, right? And we do that by making a hash of our ISO that I downloaded in SHA-256. This is the way to do it in Windows. It comes out with this math on my ISO file. And then we can look inside this file. This is just what the text file says. It's like, all right, for the desktop mode, this is the number. For the LTS one, this is that one. Or the live server version, this is the hash. So I can see this one and this one match. The file is the same. It wasn't downloaded or corrupted in download, and it wasn't changed by hackers, most likely. Question?
Not in this question. Your wife is hitting on you in guild chat.
I hope so. That's a callback to my last talk when she sent a bunch of hearts to the chat. Anyway, that was before we dated. I don't know your hardware. Size matters in this. So when you go to make your VM in VirtualBox, Ubuntu recommends 25 gigs of storage, 4 cores, 4 gigabytes of RAM at the minimum. Most computers have this available. If you're going to apply 4 gigs of RAM, you need more than 4 gigs of RAM on your computer because your computer is running also your operating system. So if you put all the memory into a virtual system, you're going to have a bad time. So you want 8 gigs of RAM if you're going to apply 4, 16 if you're going to apply 8, etc. If you can, I would set 40 gigs of storage, 8 gigabytes of RAM. Not always possible. When you get to the network settings, it's going to say, hey, what do you want to do? Do you want to do NAT? Do you want to do bridged? Just leave it at NAT. That's a networking talk. Just know that that's the one that's going to make it easy for your computer to talk to the your virtual machine to talk to the internet. If you don't know what kind of RAM you have in your laptop, use system info. You hit the Windows key, type in system info or sysinfo, and it's right there. Install physical memory. You can see my laptop has 8 gigabytes of RAM, so I'm on the smaller side. To story of my life, so I'm only going to put 4 gigs of RAM onto my virtual machine. Unfortunate. So we're going to do that. It's going to ask you a whole bunch of steps, like, hey, do you want to apply a file to the HDD? Hit browse and select your ISO. Move on. These steps are all for when you set up a virtual machine. Really just follow the instructions and leave the defaults until you select a file for the hard drive. When you finally get it booted and started, you're going to come up with this screen. This is the BIOS grub. It's grub. It's asking you what you want to do. You want to try or install. Ubuntu Safe Graphics is if you're having a lot of troubles and you want to just get it working with a lot less going on in the background. And test memory is just some hardware check stuff. So we're going to hit enter here, just like it says. Please enter to boot selected OS. And then when we get in there, it's going to give us a pop-up. And this is as easy as it is to install an operating system on your computers nowadays. They come up with a pop-up. Fedora does the same thing. I imagine there's a lot of others that do the same thing, where it's like, hey, we're going to run through all the instructions. What do you want to do? Leave the defaults for just about everything. There's some virtualization quirks. So when you get to the networking questions, you'll be like, do you want to do Wi-Fi or Ethernet? Even if your laptop's on Wi-Fi, your virtual machine thinks it's on Ethernet because it's easier to virtualize Ethernet than Wi-Fi. So you're going to say Ethernet. You're going to leave all the defaults. When you get to this page, you don't need these proprietary things because it's a virtual machine, so it's virtual hardware. Question?
At what point do I sacrifice the goat?
You sacrifice it. Well, hopefully at the beginning when you join the guild, I require everybody to do a goat sacrifice. I've been doing that behind the Catholics' back. Don't worry about it.
Yeah, guy in the blue shirt. Hey, guess what this guy's doing tonight? Because he just joined.
Oh, fantastic. So we got some. I've got to go to Pasco and I'll bring something back for you.
Ironic, that was the first thing I asked them was like, who do we sacrifice now?
Who do we sacrifice? You don't need this stuff. You don't need this stuff because we're not going to be doing a lot of media stuff. You can leave it. I don't care. It's not going to affect anything. It's going to take a few more seconds to install. When we get to this section, we're going to do manual. We're going to put her in manual. We are the arbiters of our own fate. Why do we do this? So we can learn. If you hit automatic, it just kind of takes everything in the background. You can also see that there's advanced features there if you choose that option. This is what those advanced features look like. It's not particularly important here. But you have LVM and ZFS. LVM and ZFS can both be used used with encryption. They're layers of abstraction, so they're a way to abstract your partitions. They create logical partitions as opposed to physical partitions. And I'll get into what a partition is in a second and come back to that. But just know that you don't need it. ZFS is pretty good if you're doing a RAID system. LVM is good for if you have multiple drives. I'll come back to that slide. That should be in a different order. Because we need to know what a partition is. If you have your hard drive, right, or your SSD, your HDD, you want to be able to put things onto it, and you make partitions, which are chunks of the memory storage, or sectors on the storage device. So you say, hey, this much is dedicated to these types of files, right? Why are they important? Because they compartmentalize different parts of the operating system, and I'll get into some of these compartments in a second. But for the most part, it makes it easy to, it's necessary to run the system because you need a boot partition, and it's easy to move things around between different machines or for backups. How many do you need? How many of these compartments do you need? At a minimum 2, you need a boot and the main root. If you're smart, you're going to have 3, including the swap partition. And we'll get into that in a second because I have a whole picture of that. How many should you have? If the minimum is 3, how many should I get? All tools are a hammer. At least 4? Why 4?
Your primary storage should be separated from all those other.
Home drive should be separate, or Opter, whatever your primary storage is. Yes, no, maybe. Yes, probably. Yes, you should. You should.
Wait till log file turns,
yeah.
Trashes your entire Linux drive because you happen to have it on your
when
on your root.
Yeah, things are going to break, and when they do, you're going to lose all your personal files. You should be backing them up off disk anyway. But when you get to that part, when you hit yes, I want to do manual, this is what you're going to see. It's going to say, hey, you got this much space. You can see I only gave it like 26. I thought I gave 30 gigs, but oh well. And it's going to call it SDA. What does SDA mean? It's an old term from, I think, SCSI drives. Basically, it means, hey, I have a hard disk here, right? This could be your hard drive. It could be your SSD. If it's an NVMe drive, it looks NVMe 01 or some other letters. It's kind of crazy. But it's just saying, hey, this is the name that I gave your hard drive, the little disk on your computer. And this is how much free space you have. Because I have no partitions, it's open to go. So the first thing you're going to do is you're going to say select device for bootloader installation. And when you do that, you're going to have one option in here. You might have multiple options. You choose which one you want to do. If you have multiple drives in your computer and you're doing it on a hard metal, typically you want to do that on the SSD because it'll boot faster. Otherwise, pick the only one that you got. When you do that, it's going to create a little boot partition. Oh, and there we go. New storage devices were invented. Yeah, so it was for the old drives, and they just kind of kept the format because why change something that works? And that's why we still call them SDA. If you have 2 drives that say SDA, SDB, SDC for a third one, it's alphabetical. So as you can see, I clicked on my SDA drive for my main bootloader installation, and it created SDA1. That's the first partition on my disk. It's the first little chunk of storage. It automatically made it 1.13 gigabytes because that's how much that Ubuntu likes to put there. There are minimums, and it depends on whether you're doing legacy or EFI boot. We'll get into that. It made it the type FAT32, and then I made 2 additional, right? I hit that little plus arrow, and I said, I want 2 more drives. I want 4 gigabytes for a swap partition. Swap is if your RAM gets overloaded, it stores your files that are going to continuously be loaded into RAM into this partition. It keeps your system running much more efficiently, much faster, and it avoids errors because if you don't have this partition, it's going to store all these things on a swap file in disk in your main thing, and that comes with all kinds of bugs. You can look up a whole bunch of different things that come up where Linus is like, I don't know why anybody would ever do this, like Linus Torvalds himself. This isn't an error for people who are installing Linux correctly. We'll try to fix it, but like, to just know that you need, Get good, yeah. Do things correctly. Every class that you take should do it, should tell you to do this. I'm telling you to do it. If your memory gets overloaded, this is where all the extra goes until it can catch up. Question?
How big should your swap file be?
How big should your swap file be? Well, it's swap partition. Swap partition, not swap file. Swap partition, different recommendations. I've seen 50% of your total RAM. So if you have 8 gigabytes of RAM, 4 gigabytes of RAM is what you want your swap partition to be. If you have like 164 gigabytes of RAM, that might be necessary. That might not. Your use case may vary. If there's a different recommendation.
Equal to your RAM.
Yeah, equal.
About equal.
It's like
I
2
say
gigs of RAM.
You can go at 50% and it'll run fine, but it's all, if you have the space, you should have at least as much
Equal.
a little, whatever the next sector is above your RAM, your memory size.
All right. So the expert.
Once you only got 2 gigs, then I'd just double.
All right.
Pretty much 4 gigs.
So
Yeah, if you're like running limited RAM, you should probably still, you're going to use it a lot more, so it's not a bad idea to have more.
all right. So Google says 50%. The experts here in the room say 4 gigabytes or 100% of your RAM, whichever one's bigger. So if you have 8 gigabytes of RAM, 8 gigabytes for your storage of swap. And I think I actually did that here because I only have 8 gigabytes of RAM on my laptop. So that's definitely the same size as my RAM, just out of habit. And then we do our mount point next at the root partition. And you can see that this fills up the entire rest of the hard drive on my third partition. That's just another mount point. It's the home of our file system. And we'll get into this. We were recommended in the chat here, and you'll see this everywhere, do a separate home. And that's if your computer breaks, you don't lose all your personal files, right? How big you make these things, again, it depends on how much storage you have and what your use case is. I only had 21 gigs left, so I put everything on a single partition and ran with it. This is a VM. If it breaks, I don't care. And nothing that I'm doing on here is that fragile or important. So I don't need the backup. If you're doing if you're putting this on your home computer, definitely have a separate partition if you can for your home drive. And then these are the other mount points. So you can see that we have 2 mount points here, boot, EFI, and root, which is just the single slash. When you click on it, these are all the options. You got boot, home, temp, user, var, serve, opt, use local. There's a lot of partitions that you can make, right? Home is the one that we recommend you put, and it's what you automatically put your personal files on. It's where your documents, pictures, music are by default. A lot of people will recommend a separate opt drive because that's where your optional software goes. I'll get into all of these in just a second. And slash temp, of course, for your temporary files. Never put that in a separate partition because that automatically gets deleted. I think those are all the ones that it needed special mention. Yeah. All right. So we saw that there is not only boot UEFI or boot EFI and slash boot, but also slash boot. Why are there 2? This one's pretty simple, actually. If you can choose, use UEFI. Boot is also called legacy BIOS boot, and it's essentially just a faster, more efficient, better version of the BIOS boot. UEFI is. Can you do that? Probably. This came out in 2005. This is 20-year-old tech. Most modern computers can boot UEFI and will allow you to by default. Like I said, bigger, faster, more secure. Although if someone's doing stuff to your BIOS, probably in trouble. You're screwed either way. Yeah. A big thing that UEFI can do with security is use something called a TPM chip. I don't know if you guys covered that in your hardware talk, but it's basically a security chip that very famously can be bypassed in certain ways. But yeah, it's just a better version. So use UEFI if you can. VMware is kind of dumb. I use that instead of VirtualBox just because it's what I'm most familiar with. It defaults to saying, hey, firmware type is BIOS instead of UEFI. I don't know why it does that. If VirtualBox does the same thing, you can probably find it in advanced options. Ubuntu won't let you install in UEFI unless you have this enabled. So just hit the checkbox, hit OK in the advanced settings. It'll fix your problem. If you can't figure that out, booting in BIOS is not going to make any real difference to you, especially if you're just learning on a virtual machine. You can also see that I used BTRFS for my root partition. Why did I use that instead of all of these other options? Well, BTRFS is the B-tree file system. It's a more modern thing. It's really come into its own. It's a default in Fedora. The default in Ubuntu is ext4. And ext4 is kind of like the standard that everybody is going to recommend. Every tutorial that you see that's more than a couple years old is going to say use ext4. Again, this one's kind of easy. I've used ext4 a lot. If you want to use it, that's fine. ext4 these are all just ways to create file systems. They're just ways to store data and partition drives. So These two absolutely able to be used. This is the better one that's more modern. And then there's a whole deep technical conversation you get into that. There's also VFAT, all FAT, which is file system. I'm not remembering file allocation table. File allocation table is FAT. It's really famous for being able to be used by both Windows and Linux because ext4 doesn't talk to Linux very well. And not too long ago, something called NTFS doesn't talk to Linux very well. We came out with Fuse, and so now that allows you to talk to NTFS. These are all just ways of the computer writing partitions. VFAT you want to use if you want your Linux stuff to be able to talk to your Windows stuff. Not a lot of use cases for that. And then swap is just a dedicated thing for your swap partition.
XFS can talk to Windows too, just saying, even if I am an old man.
Okay, XFS, I've never used XFS. Apparently, it can also talk to Windows, which is fantastic. So that's a good reason to use that over ext4 if you're going for these older systems. Yeah. So VFAT, obviously named after me. But yeah, so these are very high-level concepts when you get into it. It's really just a way to say, hey, this is the way that I want, the language that I want you to create these partitions in. When you're ready to give your life to the lords of free open source software, if you want to do this outside of a virtual machine, because this is pretty much what you do, and then you follow some more default steps. What's your time zone, what's your keyboard, things like this that you should be able to answer on your own. If you want to put this on your computer, you want to replace Windows, it's pretty much the same exact steps. The only difference is when you have that ISO file, you're going to write it to a USB. And this is going to make it a bootable drive. Now,
No, it doesn't. It must be a bootable drive.
right?
It doesn't make it just because you put an OSO.
You mount it. You mount the ISO to the USB or whatever device to make it a bootable drive. Yes. I might have said that wrong. Yes, you were to mount it. Yeah, if you just drag the file over, that's not going to do anything. You have to mount it. You have to write it. Now, why does that matter? Because with just this ISO file on the storage, this ran a whole Linux. This is just a pop-up for the Linux. Linux runs. You don't need to install Linux to run Linux. You can put it on a USB drive, plug it into your library computer, and say, hey, boot from my USB, which is how you'd go about installing it on your hard drive. Yeah. There's actually... Don't do that. You'll get caught. You won't get caught.
Don't walk into the DMV and do it either.
Don't walk into DMV and do it. DMV will be really mad. But this is a whole, the ISO is a disk image. It's a file that compresses all of the things you need for Linux to get started on a single file. It's really, really cool. In fact, there's entire Linux operating systems devised around that, like Tails, which is a privacy-focused one. You write Tails to a bootable USB, plug it in. It doesn't touch the storage. There's no persistence. And when you unplug it, it automatically is gone, right? Nice and sneaky. If you download Tails, you're probably on a watch list, but go for it. You're young and it's fun. So if you're using Windows, I like to use... if you're in here, you're already on the watch lists. If you're using Windows and you want to write your ISO to a drive, this is Rufus. You can just Google Rufus ISO and download the program. It's really easy from here. This is the name of my USB. I just clicked on it. It's a 16 gigabyte USB. This is the ISO file that I selected. I don't want any persistence. Persistence just means that when I unplug it, the files are saved. I don't want a persistence. When I unplug this, all my files disappear and I get to start fresh. Partition scheme, stick with GPT. There's GPT and BTRFS. Did I write that down? No. There's two versions. GPT is the modern one that works on most modern computers, and it allows for UEFI, right? So this is saying, hey, write this ISO with all these settings. This is what you name it. You can name it anything. You can name it Patsy's Ugly if you want to. It all works the same. FAT32 is the default, and the reason for that, like I said before, FAT talks really well to Windows. So if you want to plug into Windows, Linux, any other thing, it'll probably be able to read it. If you're booting into it, it probably doesn't matter. But it's nice to have. Cluster size, leave default. Don't even think about it. Quick format, don't even think about it. It's nice and quick. Check the device for bad blocks. It's just a quick check to make sure that everything was done right. And then hit start. Easy. Now you have a bootable drive. You stick it in. And then when you turn on your computer, it's going to say, hey, do you want to boot into BIOS mode? If you're using Windows, that screen will be up for like 45 seconds. Be like F12, F10, F2, delete key, whatever it says to boot into BIOS, you're going to do that. And then you say, hey, I want to boot whatever I named this device. That's what I want to boot into. And you're going to do the same thing. You're going to follow the same instructions, and you're going to install it onto your computer. If you're using Mac or Linux and you want to write this drive, that's the command. Basically, write this to dev SDA or whatever the name of your USB is. Right? Probably not going to be dev SDA. Oh, question.
If you're doing this on Linux,
yeah.
If do you want to hold it? You're good. Okay. If you're doing this on Linux, instead of using the dd command, you can also install Balena Etcher. I mean, there's a Windows app for it as well. But if you're using Linux systems, Balena Etcher is better for Linux systems. The only downside is you can't set a persistent storage or persistent, persistent partition on Balena Etcher. You can only do that with Rufus, or if you have Woe USB, which is like the Rufus equivalent for Windows ISOs, but in Linux.
It's also the same thing when it comes to Mac OS as well. It's better to use Balena Etcher.
All right, so these new...
Can I counter with that real quick?
Yes, please.
So actually, I actually agree with you on this. And the only reason that somebody would use Balena Etcher, because I've used both, is that you're on Linux. Like, Rufus, for all intents and purposes, is the superior tool.
They're talking about for Linux or...
Unix is not exactly Linux, though.
He said Linux.
We went over this.
Yeah, he said Linux. Yeah,
you were late.
And
we went over this.
Okay.
And he
Put
said
$1
if
in
you're
the nerd
using
jar.
Mac, he said if you're using Mac or Linux, so Rufus isn't available.
Yeah.
So instead of this command, there's 1,000 ways to skin every cat. People didn't like doing DD, so they made a new version to do it in Linux.
But more what I'm saying is, if you can use Rufus, use Rufus.
Yeah, if you're on Windows, use Rufus.
Yeah.
It's stupid easy. I've been doing this since 2017 when I didn't know anything, and I still use it today. All right, so after you've done all that and you've followed all the settings, you said, hey, I'm in Eastern time zone or wherever you are. It's going to ask you to make a username. It's going to ask you to name your computer. Name them whatever you want to. I don't care. I'm not your dad. Your password can be whatever you wanted to. You're in a security group, so it's probably going to be password. My 1, 2, 3, 4. My default password is something that is old that people who downloaded old versions of Kali will know. Just keep clicking next to the default settings. Make sure everything's correct. And then hit install. And then watch all of the ads as the progress bar progresses, because there's a lot of ads on Ubuntu's progress bar. And now you have Linux. You restart it, and it's there. And so now what do? We can finally start using Linux. First up, so we're going to go ahead and jump right in. So this is where we get into our commands, our CLI. We're going to go into something called the terminal, which is really, really cool. It's that thing that you see on hacker movies where they're like, oh, I'm typing in all these commands. I'm getting in the mainframe. I'm going to create a GUI in Visual Basic and track the IPs. All these great things. This is kind of where it goes. Terminals are based off of old computers that didn't have an operating system or way to click through on magical icons.
They didn't have a GUI.
They didn't.
Still had an operating system.
Or, I'm sorry, you're correct. I misspoke. This is why I love the guild.
And not just old systems don't have GUIs. Correctly set up systems shouldn't have them either.
Okay. There's a lot of systems that don't have any kind of GUIs, which are graphical user interfaces. Those are the things with the pretty pictures and the icons that you can double click. Old computers are like, oh, I typed this, right? You watch the old Jurassic Park, oh, it's a Unix system, I know this. It's just that little command line. Nowadays, for Linux, we use terminal emulators, because it's not a terminal. You have a GUI and on the operating system. It's a nice little window in your GUI, but it operates essentially the same way, and it runs a program called Bash in most cases for default Linux. There are other alternatives. There's a lot of things that you can do. And the most important command that we're going to learn that you should absolutely remember is man. That's right, man. Patriarchy wins again. Boys. No, man is for manual. Manual means that it'll take any command that you give it and say, this is the instructions. This is what it is. This is what it does. These are all the options that you can run with it. So ls, this is the man page for ls. If I run man ls, it says, hey, list directory contents. Does information about files and the directory by default. You can do -a or --all after you type ls. And it'll give you all of the things that are secret files, hidden files that start with a period. You can do almost all that ignores implicit things we'll go after. All of these things. And you can scroll down, there's a lot of lines. The man page is your manual. Every time that you don't know what a command does, you should immediately think, I'm going to read the manual. RTFM, read the freaking manual. Because that's what we're going to tell you if you ask us silly questions that you should have looked up or Googled. The other important thing is --help. There are some commands where man doesn't work, or it's just a cleaner version usually to type --help or -h at the end of the command. I'll show you that in a second when we go into the demo version. But this is the thing that you should have really ingrained in your brains. Cool. So we're going to poke around here into the Linux file system, and we're going to take out a couple more commands. If you remember back there, I pointed out a whole bunch of cool little directories. There was like /dev, /boot, /root, /srv. What are they for? We're going to take a look for ourselves, and we're going to go ahead and start a terminal. So let's go into demo mode and see what happens. Pray for me. Oh, Satan, let this. All right, we have a Ubuntu VM. So once everything's up and running, this is what Ubuntu looks like. If I want a terminal, I'm going to hit that little super key or the Windows key. I'm going to type in terminal, and I have a terminal emulator, Patsy ABS Ubuntu. That's my username. That's the name of my machine. All right. So
that's awesome.
So
That's a good name.
thank you. And then can I do commands here? I can. Huzzah. All right, that's as far as it zooms for this. All right, so if we look into here, we're going to see a whole bunch of things. The ones that we saw, there's opt, there's root, there's an awful color scheme for this. sbin, run, proc, mount. If you don't know what these are, if you have a question about things in Linux, what do? Not Google. I literally just told you guys. Man. All right, so if you Google it, you'll find man, and there's actually a command for this. It's higher, for hierarchy.
Wait, what?
Man higher. You didn't know about this? I didn't know about this till I didn't know about this either till I started writing this. Man higher. Yeah. This is a description of all of your main Linux system file systems.
Higher Linux.
Yeah. So, all right. So we'll go into it. The slash. That's the root directory. This is where the whole tree starts. Yeah. Bin.
When did this come out? This wasn't around when I was doing my Linux class. There's no fucking way.
Probably was.
Yeah.
It's definitely. Yeah, here.
2017?
Yeah. I don't know. I've been taking Linux classes recently, and this is one of the things they point you to. Wow.
This is something that I discovered after 8 years writing this talk, so don't feel bad if you didn't know. So this is an example of a description of all the things. And an example of the power of man, right? Bin contains executable programs which are needed for single user mode. And we're going to go ahead and put this in the background actually if we can, just so that we can have a better look. Oh, look, yeah, and I gave an example here. Quick list of all of them. These are some essential commands. We've got cd, print working directory, and ls. cd is for changing the directory. So these are navigation commands, and we're going to go ahead and get into this before we continue on to the file system. And I should have done that in the first place anyway. So if I wanted to move around into the terminal and find all the files, I want you to picture your... All right. I want you to think of this like a normal computer where you have your C drive, and then your user, and then your documents, your pictures, your music, right? These are all just folders that contain your files. There, it's a file system. So if I wanted to see, and I don't, oh wait, it does. This is the VM. This is not my workstation. So if I hit ls, which is that command that we saw in the beginning, list files, ls. There we go. I can see, oh, this is my desktop, my downloads, my documents, my pictures, my public. We've seen this in Mac. We've seen this in Windows. So ls lists all the files here. If I wanted to see which directory I'm in currently, because these are all directories or folders, I would do print working directory, pwd. These are all named very, very intuitively. ls is for list. Sound it out. pwd, print working directory. So right now I'm in the home Patsy directory, right? That's my user's home directory. If I wanted to change the directory, if I wanted to go into documents, I'd say change directory, and let me see what's in documents. And I hit ls, there's nothing in documents. If I hit print working directory, I'm in Home Patsy Documents. This is how easy it is to navigate in the terminal. So whenever you see someone doing some crazy stuff, this is all they're really doing. If I wanted to go backwards, right, I can do the special little command, ... One dot is for your current directory. So if I hit cd dot, I am in the same place. If I hit 2 dots, 2 periods, I go backwards 1. So now I'm back in Patsy. I went from documents back 1. And this actually exists. We're going to go ahead and look at ls and do one of those flags. Remember -a in the man page that was all? I can do -a. I can do --all. They mean the same thing. They do the same thing. We saw that. And I'll actually open it back up again. Now, instead of here, where we have all these normal files, we have these secret hidden files. The NSA knows about this. This is not the way to hide your secrets. But it hides it from normal view. And if you open it up in like a normal file viewer, it'll hide these by default. But if you look, we have in the beginning that dot and that ... It recognizes these. So you're actually changing directories into...
If you don't hate yourself, you should add an L as well to the end.
ls. Oh, okay. Yes. So if you like a prettier version, you can do AL. We didn't see this in the man page, but actually, you know what? Let's look for it. Man ls. He said I should add a -L. What is -L? Well, in a man page, I can scroll through with the arrow keys, right? There's no fancy way to do that. It's all on the keyboard. So I can go down, 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 down with the arrow keys, right? Or I can hit /, and that'll activate the search, right? So /-L, enter. All right, and now I'm finding each one. So there's a whole bunch of -Ls. I'm going to hit enter until I find it. Or, I'm sorry, what was it?
Or if you add a space, it should go straight.
Oh, maybe. Let's try that. Space -L. No.
Oh, I meant space after.
Oh, yeah, that's also a good point. Search /L, enter. No. But we're just going to keep hitting the next button. There we go. Use a long listing format. Now, that's not necessarily helpful unless you already know what it means. But what does that look like? Well, let's just try it out. So A, we're going to keep all, and L. 2 different flags, 1 little dash. It's in a list format. And it's just prettier to read. You can see at the top here we got their current directory and our previous directory. These are the way that Linux navigates, right?
Pro tip, if you want to use this function by default or in general, if you replace your thought process of ls with ll, that does that exact same thing.
Yes. So
in most distros, in the ones that matter.
Yes.
Like Arch doesn't work.
You can make it do that in Arch with aliases. We'll get into aliases. But yes, LL does ls-al, right? There's a lot of flags that you can use to everything, right? -H makes it human readable, or ls-h. There you go. So we get a whole bunch more information with this, when files were last edited, some weird letters we'll get into later, my name a whole bunch of times and this root guy, and then the size of the file, right? So kilobytes, bytes. I don't think there's any megabyte files in here. All right. So yeah, this is the basic way to, and then clear to make it pretty and empty again. These are your main navigation commands, right? cd, ls, print working directory. All right, moving back on to my slideshow. All right, so we're able to see, in the root directory, which is /, it's the very, very top of this file system, we see all these things. Oh, how do I remember all these commands? If you don't know, there's 1,000 Linux cheat sheets with all the commands that are like the most common used. Google them, download them, print them, use them. So like I said, if we want to picture a file system, we know what Windows looks like most likely if we used a computer before. You got C, and then you got users, My Documents, Windows. Linux works kind of the same way. We have root, and then all of the things that come out of root. All right, we got home, which is what we've already seen on the bottom there. Var, user, temp, sys, proc, root, all these kinds of things. I'm sorry? Root comes out of root, yes.
You can only access root with root.
You can only access root with root. Now, why is that? Why do we have a root in the root directory? Well, because root is also a user. You have the root user. Where did my VM go? It's the default user, yes. Now, most distros are idiot-proof and they don't let you just use the root user. But if I go into the root user, I can't do it. Can I just do this just for an example? Is it going to let me? No, it's not, because I don't have a root password set. All right, so we'll get into sudo and just, actually, let's just do it now. Yeah. Oh, it's sudo tech-i. That's right. All right, so root. All right, so if I am root, if I cd into my home directory, because cd by itself puts you in your /home/user directory, we'll see what my print working directory is. /root. /root is the root user's home directory. It does not go in home, it goes in /root. There's a few.
That's a security feature.
That is a security feature. Other users shouldn't be able to access the root's home directory, and you shouldn't be putting personal stuff in here. So if you don't put root in a separate partition to protect all of your documents, like we see in home Patsy, right? We'll go in ls, and we'll look into what that directory has. That's all my documents, downloads, everything. If I save all my music in here, and I save this partition on a special drive, or a special partition for backup, so that if the rest of Linux gets corrupted, I don't lose this good stuff. You don't necessarily care if you lose the stuff in the root directory, because if you're using the root directory, you're doing it wrong. You shouldn't have any personal documents in your root directory. If I'm done there, I can just hit exit. So that's kind of a look. Sudo-i is great if you want to start doing things as root. It's elevated privileges. It's like running as administrator in Windows. It's generally not recommended if you're doing everyday stuff. It's only if you're trying to modify things or do things that are advanced user stuff. So we see all of these, and we see that there are a lot of directories here. And like we said, we can go into man hire and see what they all mean at the speed of VMs. Come on. There we go. All right. Cool. So we got the root directory. It's our main directory. It's the top of our file system. It's where everything is stored below. You got bin, which is executable programs needed in single user mode to bring the system up or repair it. These are your really base level programs. Let's take a look at what is in there. ls bin. We got things like, what's a good one that we're going to look at? zgrep, I guess, kind of. Nano. Nano is a text editor. We're going to need that sometimes. Make temp, make squash fs. These are good things for modifying your files for the system. These are all the things that really like man. There's more that I want to bring up, but it's fine if we can't find them. If anybody has any off the top of their heads that they want to mention that are going to be in bin, that would also. Kill is a good one. We'll go over kill in a bit. So all these like low-level commands that your system kind of needs to run, they're going to be located in bin. If you run a man page on some of these, I believe this is the correct thing, you can just follow that and look around, figure out what they do. Absolutely do that for some of them. Look up the popular ones. Man hire. Our next is going to be boot, I believe. Yeah, boot contains those static files for the bootloader. Boot,
Don't mess with boot.
don't touch boot. It is in a separate partition. It's in the first partition and is in that way for a very specific reason, because you don't want to modify it. It's the instructions for how the computer turns on and runs Linux. If you mess with that, your computer doesn't turn on and run Linux, unless you know what you're doing in the way that you modify it. Dev is for special device files, which refer to physical devices. So if you have things like printers, you're probably going to find them in dev. There's also some pseudo devices. We'll get into that.
Everything in Linux is a file, so that's why you have dev.
Everything is a file. And what does that mean? Only nerds know. We'll get into that. Etsy for your config files. So if you have things that are just set a certain way, you want to modify them, the way that they run, the way they operate, the way they look, you're probably going to find it in Etsy. Host-specific files, you're going to find in Etsy opt. There's a lot of Etsy folders. It's just a whole bunch of configuration files to change the way that the system runs. Your home, we went over this. This is your home directory. This is where all your personal stuff goes on. Every user gets their own directory in home. Asterisk, you can set the home directory to things that aren't in home. But for the most part, by default, if I make a new user for my wife and I say, hey, here's your computer, her personal files will be stored in home wife, and mine will be stored in home Patsy. Lib holds the directories that are necessary to boot the system. commands in the root file system. This should be kind of familiar. Let's go ahead and take a look into. Come on, quit. I apologize. This is the slowest VM that I've ever made. We're going to switch things up in live. Where is my PowerShell? Because I am running out of time. All right, so let's take a look at lib. All right, we got X11, we got AppArmor, we got a whole bunch of things that are just libraries for the system to run. All right, there's opt. Opt is for your special programs, your optional programs, software that you download and you want to save. By default, root is the one who has permissions on opt. It's very annoying. It's very awful to use. I don't ever use it. I put all my personal stuff on my home directory. But it's one of those things where it's like if you have an application that you want to save binary, you throw it into opt. Media is for things like USBs that you plug into your computer. Mount is if you want to mount other drives to your computer. That's where you would do it. So say, hey, I want that network drive accessible on my computer. We would mount it into /mount. And if I have time, we'll get into that. Proc is for all the processes. Temp is a temporary directory where everything will be deleted when your computer shuts off or restarts. And just hold your temporary files for easier access. So that's a pretty brief overview of these. And as you work in Linux, you'll get more familiar with some of them and a lot less familiar with a lot of them. Demo time. I am using, as you saw, Workstation for Linux on my PowerShell. I guess I timed that perfectly with how the VM failed me. Workstation for Linux is a cool little tool that I've recently become a big fan of. This is a Windows PowerShell window. I typed in WSL and I had a Linux system up and running. How did I get to that? Also, why didn't we use this in the first place? Because it's so easy. Because we're not half-assing things, we're whole-assing things. So we got a whole VM going, and that way you can get your whole computer running. I'm a reformed hater of WSL. I really hated it until I couldn't get virtual machine software on my work computer, and I was forced to use it.
Side note, there are a bunch of security flaws in WSL.
I believe you. Oh, yeah, it's cool.
It is really handy. When the Windows OS decides it doesn't want to do what you want it to do, it's really handy for fixing that.
When IT decides that it's too much of a security risk to approve my VMware, then I'm using WSL to get my job done. And if they like that, then that's a security risk that they accepted. How hard is it to install? This is how hard it is to install. I typed in WSL. It said, hey, you have no installed distribution. The first time I typed it in, it said, hey, WSL is not installed. Do you want to? I said, yes, hit enter, rebooted, and then I got this. Windows Subsystem for Linux has no Linuxes on it. If you want to view what you can download, use this. OK, I did that, and I saw in the list was Ubuntu. When you're ready to install it, say -- install distro. So I did that, WSL -- install Ubuntu. Went through all this automatically. WSL was done. Linux was installed. Like 3 or 4 commands. It's really easy to get started, and it works. It works actually really well. And then whenever I want to access it, I type in WSL, hit enter. I have a Linux terminal ready to go. But again, we're not half-assing things. And when you want to get Linux up and running on your computer, this is what you do. Here's a quick view of your home directory or your root directories and a quick description of what they are. And as mentioned before, everything in Linux is a file. All right, so we see all these things hold files. It's a file system. Everything is a file in Linux. And everybody keeps saying this. And very rarely do I ever hear anybody explain what that means or why I should care. Right? As a guy who came from Windows, I didn't know that there was another option. Because Windows doesn't explain that not everything is a file. Yeah, this is the first. Like when you switch to Linux, you're like, oh, everything's a file. That's cool. Who fucking cares? Is there even an alternative? What would the alternative be? What else would you use besides a file? So the important thing for what this means is everything is a file, including things like devices. So if I plug a USB in, Linux registers that as a file. It reads that as a file, right? Your printer is considered a file in Linux. Your TV, your monitor, every device, everything that you do is considered a file. And that's pretty cool. And why is that cool? Because it's really, really powerful. It's really, really consistent. It's really, really flexible. The alternative is things like Windows, where things run on like API calls. So like Event Viewer. If you want to run any kind of application with Event Viewer, you have to work with the Windows API for Event Viewer that was written back in the 90s. It's a real pain, and it's not very flexible. And if you want to change it, go cry because it's proprietary Windows software. Is this unique? No, not even a little bit. There's a lot of things that make things files, but it is defining for Linux. And like I said, Windows binaries, the registry, the Event Viewer are all based on APIs. And they need special software tools that you have to interact with. So when you mount devices, that's a file. If you mount a share on your network, like, hey, this is my company's D drive, you mount that to your Linux system, it's considered a file. Other computers that you connect to, believe it or not, file. So let's play with files and look at Nano Vim, and we are at 15 minutes, so this is going to fly. There's a big debate between Nano and Vim. These are just text editors, so if you open like Notepad, they do the same thing, but in terminal. Nano looks like this. We'll go into home directory. Nano, pretty. It's a text thing. If I type into it, this is text. I can edit text. If I hit Control X, as you see on the bottom left there, there's all these commands. It'll exit. Do you want to save? Yeah, sure. What do you want to name it? Test.txt. Why not? Hit Enter. Easy. That's ls. There it is. I made test.txt. Wow. Fascinating. Nano is fantastic if you're a quitter and you're in a hurry and you don't want to learn anything. Real men use Vim, and women.
Nano greater than
Oh, I'm sure you fucking hold the crayon like this and you color too. You just want to eat it.
All right. So I can use Nano to make new files. I can use Nano to open this. Look, there's that same stuff.
In Nano. Oh, wait.
If I use Vim, I can use Vim in the same way. I can use Vim by itself. I can use Vim without the caps lock key and open my text file. And there's the same thing. The only difference is if I hit A, oh, not A. If I hit the P key, if I'm in normal mode.
This is why Nano is
Yeah, I hit it. All right, I hit P, and all these lines with J come out. Right. So I hit P, and this does it a lot. There's a whole bunch of J's. Right. The strength of Nano, and the reason why people prefer Nano when they have the time to learn.
Right, I'm hearing a lot of fucking mouth breathers here going off about Nano here.
The reason why people who are efficient and care about getting things done in a fast way when they learn something is if I hit 0, and then I go to the line. I forgot the commands. It'll take me to the top. If I hit, I want to delete all these lines. I'm going to do 100 DD. Clears all the lines. If I want to type in into it, I hit I, insert. This is text. If I want to copy and paste, I'll enter YYP. Copy, paste the line. If I want to do it 5 times, I'll hit 5 PP. It's really, really quick. It's really efficient. And when you remember the commands.
Otherwise, all the time, Nano is better.
A lot of them are pretty intuitive, like what the commands.
Some of them are intuitive. If I want to find and replace. If I want to find and replace every instance of the word text with the word cry normie, I could do that. Boom. Instantly all versions, right? If I want to exit Vim, I Google how to do it instead. Same kind of thing. It uses regex-like, right?
Who's using sed?
I use it on
People who use Nano that want to get things done without.
You're dogging him for using Vim and you're over here using sed?
Well, Splunk pretty much requires it those days.
Womp womp. If you want to exit Vim, you hit :WQ. It saves the file. It's not that complicated. And if you really want to learn it, Vim Tutor. Is that not it? Vim Tutor? Yeah. No. There it is. Yeah. Vim Tutor is a command, and it'll teach you how to use Vim. And it's idiot proof.
Vim Tutor does?
Yeah. Vim Tutor is a great thing, and it teaches you in Vim, right? So like, hey, here's how you move the cursor. Is it intuitive? No. You use HJKL, right?
Why?
because when you get used to it, it is a lot faster.
So actually, Vim was originally designed to be used. Like if you look into the history of it, Vim was designed to be used to have one hand while the other hand holds a sandwich. And no, I'm not kidding. That's what Vim was for. Is you had these dumbass 1980s sysadmins. One hand they're Vimming, the other hand they're stuffing their face with tacos.
Honestly, lucky then.
Honestly, it doesn't matter. I don't care. You're never going to be able to keep up with the technology. NeoVim is the current elite. I got roasted now because I don't use NeoVim.
That's an important lesson with Linux, though, is no matter what you use, somebody else who uses Linux will roast you for it.
Right, and they'll be correct, right? NeoVim is... Yeah, NeoVim is objectively more efficient when you learn how to use it. I can't be bothered. I'm too old.
Some Third Reich Vim over here.
Huh? Yeah.
I just like Vim.
Yeah, well, and that's the thing, right? Go back to the Linus philosophy. Whatever tool gets the job done the fastest is the one that you know how to use. So if you know how to use Nano, use Nano. If you know how to use Vim because you took 30 seconds to learn something, use Vim.
30 seconds.
Yeah.
Patsy, we're gonna talk in the parking lot.
All right, our torments may in length of time become our elements. Paradise Lost, John Milton. Yes, you will suffer, but you will become, it will become your element. These torments. So we're gonna go ahead and look at dev now that we know how to interact with files. But real quick, how long am I allowed to take this? Because I got a lot more.
I'll tell you what. Here's what. Macho, do you want to kill the stream at 9:15, and then Patsy can keep going if he wants? You guys want to kill? Okay, hang on. By a show of hands, who wants to kill the stream at 9?
I have no
Okay, we'll keep it going, and when Macho and the rest of the guild feels like taking us out, we'll.
I'm gonna keep talking, and if you need to leave, you need to leave. We'll kill the stream when we need to kill the stream. I'm gonna quickly go over some more of the basics that you absolutely need to have. So let's go ahead and do some things like touch echo, move, copy, make directories, right? There's a lot of ways to interact with files. Vim and Nano are great ways to edit the files themselves. And now we have a file in here. What if I want to read it without going into Nano and Vim? That's really just a lot of work. I want one command. Cat, right? What is cat? Yes. Concatenate files. It's the thing that you're going to see all over the place. What does that mean? It's going to print the file. I hate cat test.txt. There's all the things that I wrote in my file. It exists. Hooray. There's also other things that I can do with the terminal. I can do things like echo. What does echo do? Guess, right? Echo. Echo. It repeats the thing that I put into it, right? It repeats whatever you say into it, right? I think it works without quotes, but we're going to try that.
It works without quotes.
Okay, yeah. This is a cool thing. Yay! It repeats the things. All right.
Type in. Never mind. I was gonna say type in as a password.
Anyways, so yeah, we also have more or less tail and head, right? If you have bigger files, like let's say, does it exist in this? Yes, it does exist in Workstation Linux. If I want to read my bash rc file, which is just like a kind of configuration file for bash, which is the program terminal runs. It's long. It's kind of annoying to scroll. I don't want to scroll. That requires a mouse. What nerd uses a mouse? I'm on Linux. So I'll hit something like more. If I type more .bash rc, which is the name of the file, it brings up this. This is the top of the file, and I can use my arrow keys to navigate, or I can hit the N key or search key and search through it, right? So alias, right? There's a lot of things that I can do. It's just much more efficient. What if I only want to see the top of a file? I want to see the head of the file. .bash rc, there's the head of the file. What if I want to only see the bottom? Tail. That's the bottom of the file. Really, really easy stuff. Again, how do I remember all this? Get a cheat sheet. These are common commands. You'll remember them forever. What if I want to make a file without going into Nano or Vim? Because again, who has time for that? You'll use touch. Now, touch technically changes the timestamp of a file. But what everybody uses it for is to create a file. I want a file to exist. I'll say new file.txt, ls, new file.txt exists. It is empty. I cat it. There's nothing in there. Yes?
Capital N new file.txt is a different file.
Correct. Yes. Yeah, so
Linux is case sensitive.
Linux is case sensitive. So this file is different from this file, right? Two different files, one with a capital E. They are text sensitive. What if I want to like quickly type out a command, right? Like I want to cat new file. I don't want to type out new file, so I'll hit tab twice, or I'll hit tab, boom, and it auto completes. Hit enter, boom. What if there's two files that are similarly named? I'll hit tab twice. It'll show me all of my options. I got one with a big E, one with a little e. Let's do the big E. Boom. What if I want to see all of the things that I can cat? Double tab rather. There's all the things that I can cat, right? Linux has an autocomplete. The autocomplete key is tab. If I wanted to do
Tab is your friend.
tab is your friend. I use tab more than any other key in existence, right?
First switch to fail on all my keyboards.
So if I type .ba and I hit autocomplete, it'll autocomplete until like the first example, right? So bash can either, the next character can either be an underscore or an R. So let's do underscore.
What does the dot mean?
We covered that.
Yeah.
Yeah, we covered that.
Yeah, the dot is for the current directory, right? So if I wanted to do something like cat this directory, right? Because .1 dot is our directory, right? Instead of saying like home Patsy, I could say my current directory, new file. It auto completes, and there it is, right? Still empty. I will go ahead and do cat test.txt, right? I can also do the previous thing. So if I want to go cat Patsy, oh well, there's nothing in there. If I want to do ls // Patsy, or // in general, boom, there it is, right? Patsy is in the home directory, right? It lists everything in the home directory. The only thing in there is Patsy. At least that's not a hidden file. All right, so these are some of the ways to kind of explore. What if I want to make a new folder, right? I go into Documents. Do I have documents? I don't have Documents in Workstation Linux. What if I need a Documents folder? I'll make Directory. Documents. Boom, it's there. What if I want to make a new directory inside of that directory? Make Directory, Documents. Boom. New file, new folder in my directory. All right? And then I can touch Documents and then say of.txt or password.txt. Cat Documents.
He had this set up before.
ls, let's see what's in my Documents folder. Boom, the file exists. These things can all be used together. And this is where some of the real power comes from, because if I can do all of this to my files and directories and send all these commands to it, I can do that with all the devices in the world that connect to Linux. If I'm sick of something, there's rm. Be very careful with rm. If I want to delete new file, I just type rm new file. That's it. It's gone. There's no warning. There's no are you sure? It's gone. I've lost a lot of stuff doing this. Be very careful with rm. A lot of smart people will make a command like Patsy rm or something, their prm, and they'll alias it. So let's go ahead and look at that. An alias is when I want to make my own command do something, right? It's like a shortcut. So in default bash, that's stored in the .bashrc file or .bash aliases. So -al. There's .bashrc. There's no .bash aliases. We won't worry about that. vim.bashrc. Just do it in here. All works the same. I go all the way to the bottom. Probably a faster way to do this. Who cares? And we see that there's already some aliases that exist, right? ll is alf. la, right? These are the list things that we saw. I want to make a new one. So I want to say, when I say alias prm Patsy remove, go ahead and say move to home Patsy.
Change it to Patsy Smash.
Smash, right? Move this file to Patsy Smash, right? I need to.
Hit the wrong.
I did, yes, right? I'm doing this in Vim, so I'll hit Escape WQ. For those of you who couldn't figure out how to exit it, that's how easy it is. I'll make directory Smash so that I have my remove thing, and I'll say prm new file.
Patsy Smash.
PRM new file. Oh, reset. I have to restart my terminal so that it loads in my alias. You just hit reset and it does that. PRM new file. It's the demo gods. There is something that I'm missing there. There's a way to reset it. Cannot overreact.
Source your bash RC file.
Yeah.
your RC file wouldn't work related.
Okay. You can make aliases. There's a smarter way to do this. You can Google it because I'm running out of time. I have a page for it that does it correctly. You're supposed to make a .bash aliases file, and then say alias rm equals move to home Patsy smash.
Yeah, you're basically trying to like overwrite it with a folder. That's not really relevant. You actually need to script that out correctly.
All right, there's ways to script out how to do this correctly. I obviously did not prepare that correctly.
That scripting should be your second thing that you start learning after you feel comfortable in Linux.
Yes, I have Linux scripts. They are not for this because I just suffer from my mistakes of using RM. All right, cool. So I can also move files. We showed that if I want to copy files, I can say copy test.txt to smash, ls smash, ls here. We can see there's two test.txts. CP is copy, easy. Move files we went over, move from here to there. And then file, right? What if I want to figure out what kind of file this is? I can say file, new file. File, test.txt. It's a text file. It's an ASCII text file. What if I want to figure out what kind of file documents is? It's a directory. Easy, right? File gives you some information. ls-a. What kind of file is, not really anything here. File, bin. Yes, list all of the possibilities for me. We'll do seq, why not? It's an ELF 64-bit Pi executable file. All this other information stripped, right? If I want to figure out what kind of file something is, I can say file and it'll show me. Cool. All right. How much time do I have? It's 9:02. Let's go ahead and look at outputting two files, right? So these are called redirectors in Linux. So say I want to do something like echo hello there, right? That's great. What if I wanted to put the output of the terminal onto a file instead of the terminal itself? I can do something like this. So you're going to take what this does, this little greater than symbol says, hey, instead of my standard output, which goes to the terminal, I want you to put it into this file. So I'll hit enter. It created the file. And now my text is there. You'll see it didn't echo it into the terminal. It echoed it into the file.
Be careful if that file exists, though, because that overwrites the file with one.
Correct. If I wanted to echo something else into General Kenobi, and now I cat General Kenobi, it has replaced hello there, right? So what if I don't want to do that? What if I want to add that information instead?
That's where I lost most of my data. It's usually for getting the extra.
We add a second one. We add a second redirector, and now I'll cat General Kenobi, and it added it in a second line. Very nice, very fancy, very important, right? Because what does this mean? I can write any kind of output into the terminal into a file. And in Linux, what's a file?
Everything.
Everything, which means that I can write any kind of output from the terminal and from any command that would print out to the terminal into a file, right? So what's kind of happening here in the background? You have three kind of standard libraries that we're interacting here with here in the Linux terminal. You have standard input, standard output, or standard error. So standard input is what you type into this line in general. So if I say echo your dad, the standard input is echo your dad. Standard output, your dad, right? If I do something wrong and I say echo, well, let's do ls that, right? Invalid option, that should be an error. So the third one is standard error. Whenever you have an error output, it's going to print out that. So if I say output or put this stuff into General Kenobi, it prints this. It puts this into my terminal, into my standard output, instead of the text file, right? This should have overwritten General Kenobi. and it kind of did, right? But there was no standard output, so there was nothing to put into it. It just overrode it with nothing because there was no standard output. That's because standard error is a totally different thing, and you can redirect it with something like this, right? The second version of redirect is a way to think of it. 2 greater than will redirect your output into the file if it's an error, right? So now we'll cat general Kenobi. It's my error code, right? This is really great if you want to run commands and figure out why something doesn't work and you automatically just port it to a file. You can save it. Huh? Or if you don't want to see all of your errors, you can send it something called dev null, right? If you remember, we said, hey, there's this thing called /dev, and it's where all the devices are. But there's also something called pseudo devices. What are pseudo devices? You have 3 generally useful ones. There's a lot. You can have like dev full, dev, I'm forgetting the non-common ones, but the 3 main ones that you'll see are dev 0, dev null, and dev random. Thank you. Well, urandom for the better version. Yes, random does exist. Urandom is the better version, quote unquote. It's got better entropy. The only caveat is you got to let it run longer. I'll go into that. So what does dev null do? It is screaming into a black hole into the void. Right. So if I want to echo hello there into dev null, nothing happens. That standard output didn't go anywhere, and all I got in return was something called an end of file. It's basically saying, hey, nothing here, move along. Right. There's also things like dev 0, which when you run returns just an infinite amount of zeros. This is good for doing things like zeroing out a hard drive. So if I want to say dd, which is write to disk, essentially, in file SDA, out file dev null, or dev 0. This is going to write my SDA drive with a whole bunch of zeros. I'm going to say in file SDA, out file, just write zeros all over this thing. It's great for wiping a drive. It's not very secure. I'm not going to do that.
I thought it was going to go for
Do
it.
it.
Do it.
Yeah, do it.
You got to give us a hands-on experience.
No, I don't. You could also do urandom, right? This is a better version, in my opinion. Takes a little longer, but this is going to write randomized output into the thing. This is cryptographically secure to whatever degree you trust cryptography. It's actually fairly secure. This is just, if you know anything about cryptography, it makes a seed based on the entropy of your system, and it outputs a whole bunch of random data. If you write this to your disk, it's a lot harder to recover the information for people who do that for a living. I don't know if it's perfect. I don't do decryption or file recovery or anything like that. If you do it over and over again, yeah, you're probably safe. If you do it once, you're safe from 99% of the people because you're probably not doing things where people want to do that to recover your files. We know that because we're Linux nerds and we're paranoid and we hate the government. But these are the 3 pseudo devices that you'll see all the time. The null, the 0, the void, and the random. Random is the older version that isn't really used anymore. You'll see it everywhere, but urandom is the better version cryptographically. Want to make sure that we get to all of the commands that are really important. All right. Which, so type in, what is which? Man which? Thank you. Which returns the path names of files. What does that mean? Well, if I have a command, let's say Python. I want to know which Python. Well, let's see what command we know. Which ls, right? This tells me which version of the which binary is going to be run when I type in a command, right? So every time you type in ls, it's running user bin ls, and I can prove that by saying run user bin ls, right? It does the same thing that ls does. There's a little bit more color. There's a little bit more functionality to it by default because of the alias, which we'll look at. Actually, that's a really good example. tail.bashrc. Maybe? Nah. All right, too much work. There's commands that are written by default into Ubuntu, some extra options that give you the colors. But that's what which does. All right, so if everything is a file, then I guess modifying files is pretty important. So if I have vim test.txt. Perfect. All right, clear. I have this, right? And let's do ifconfig real quick. That'll give me a better example. Network information is very important. If you've heard of ipconfig, ifconfig is the old version for Linux, and it gives you just what your IP address is, what your network interfaces are. There's a networking talk that you'll be able to focus on that'll go over what the network information is. The modern version, because I'm pretty sure Ubuntu doesn't use this anymore. Yeah, no, ifconfig is for old people. It's gone. Use IPA. IP all. Old people, that's right. IPA gives you the same information, but better. ETH0 is my Ethernet device. And my IP address associated with that is that inet 172 blah, blah, blah. That's a lot of information that I don't need. I want that one line. So what can I do? I can do a command called grep, right? So let's save this information into a file. And we'll say ipa.txt, cat ipa.txt. Whoa, it's in a file automatically, magic. I can grep that file, which is just a search mechanism that goes through files and pulls out what you searched for. So I'll say grep inet out of the file ipa.txt. Here's all the examples where inet is shown. I don't need all the IP6s because that's irrelevant. So we'll do inet space. Yay, still not enough. So if I want to do this and I don't want to save it into yet another file because that's really annoying, we'll do something called pipe. And this is a really, really popular and powerful tool. If I use this shift backslash right above your enter key, usually this straight line thing, this is saying, hey, instead of putting standard output into a file, put it into my next command, right? So it's going to take this output that I got, and it's going to put it in the next command, and I'm going to say I want the one that says ETH0, right? Two of these end in LO. One of them ends in ETH0. So say grep ETH0. I don't need to specify a file because it's already getting that. It's getting that from the standard output. Boom, one line. Fantastic. But there's still a whole bunch more junk in there that I don't want. So there's another command. Let's pipe that output to something called cut. Cut is pretty easy. It takes a delimiter. It says, hey, for every space or whatever thing you want, comma, slash, period, numbers, every time you see this thing, separate it into a different chunk, right? So I said cut slash d dash d with a space. It's going to say, all right, this is one chunk, space. Second chunk, space. It'll go left to right. Why is that important? Because it numbers them. And I could say dash f, which is for field. And I could say, all right, I can see that there's 5 spaces to begin with, and then inet is the 5th option or 6th option. So it's 6, and this should give me inet. OK, 5th option. There's only 4 spaces to begin with, right? So you can see 1, 2, 3. Why am I pointing? 1, 2, 3, 4, inet. So my 5th option is inet. The 6th is my IP. It's still got that /20. I don't want it, so we're going to cut again. Dash cut, or cut, dash D, space. And then I want, or slash. So there's a different delimiter. I say split this up, separated by the slash. So it's going to have 2 fields. I want the first one. One command, and I get my IP address as the output. I don't need to do all of that other steps. I can copy and paste.
It's time to say goodbye. Hello. say